Okay, this video goes with 6.2, student companion, kites and trapezoids. So let's see what we got. Manuel's designing a kite-shaped keychain. He draws this kite with QS as a line of symmetry. Now this, in terms of vocabulary, this vertical line here, we're going to end up calling a major axis because it's the longest diagonal, or major diagonal rather, which means that this dashed line that we'll talk about in a little bit, we're going to call it the minor diagonal. And let's just kind of talk about this kite. Now, a kite is defined as a quadrilateral, has four sides, that has consecutive pairs of congruent sides. So let me get rid of this notation here. So we're just going to talk about this major diagonal. Now, this major diagonal, we can see, cuts this kite in half. So a kite, though, is defined as a quadrilateral that has consecutive pairs of congruent sides. So this QP and QR side have to be congruent, and the PS and RS sides have to be congruent. Now, if we look at the diagram here, we can see that these two triangles, QPS, is going to be congruent to triangle QRS by side, side, side. This side is shared between the two triangles, and we have three sets of sides that match between the two triangles. So these two triangles are congruent. Now what that does in terms of this shape, though, is give us this angle PQS and this angle RQS are congruent because these are corresponding parts of congruent triangles are congruent. And also down here at S, at this S vertex, this angle PSQ is going to be congruent to this angle RSQ. So in effect, this major diagonal in a kite bisects angle Q and angle S. Now we're going to call Q and S the vertex angles. So the major diagonal bisects the vertex angles of a kite. Major diagonal bisects the vertex angles of a kite. Also, what we can do is, from these two triangles being congruent, we have this angle here at P and this angle here at R that are in corresponding positions. These two angles are congruent. So this angle P and angle R are congruent. Angle P is congruent to angle R. And also because those are corresponding parts of congruent triangles being congruent. So if we call angle Q and angle S the vertex angles, we call angle P and angle R non-vertex angles. So in a kite, the major diagonal bisects the vertex angles, and the non-vertex angles are congruent. And the non-vertex angles are congruent. So that's what we can do to kind of start with in our first discussion about a kite. Now a kite, again, is a quadrilateral, consecutive pairs of congruent sides. That sets up, if we need to argue the case here, that sets up two congruent triangles by side, side, side. Corresponding angles are congruent, which gives the vertex angles being bisected by the longer diagonal, which we call the major diagonal, and also by corresponding parts. These non-vertex angles, or like the shoulders of the kite, are going to be congruent to each other, also because of corresponding parts of congruent triangles. So let's look at the notes. Okay, so we got that part filled in. So which of Manuel's conclusions do you agree with? Now this one here we need to talk about a little bit more, the perpendicular part. QP congruent to QR. QP is congruent to QR. That's one of the pairs of congruent sides. SP congruent to SR. That's the other pair of congruent sides. That's what makes it a kite. PR bisects QS. PR bisects QS. Doesn't look like that's going to work. Triangle PQR is equilateral. Well, if it was equilateral, this PR length would have to be the same as PQ. It doesn't look the same. Let's look at triangle PSR. PSR is isosceles. Yes, it is, because these two sides are congruent, and an isosceles triangle has at least two congruent sides. So this triangle PSR is an isosceles triangle, which means that even though these two angles are congruent, that this little angle and this little angle there, like angle SPR and angle SRP, are also going to be congruent because these are base angles in this isosceles triangle. So that seems to be true. Okay, that's part A. What other conclusions are supported by the diagram? We still need to talk about this right angle part here. So let's look here. So I'm going to draw a kite. Okay, it may not be to scale, but I'm going to mark it as a kite. So we got the consecutive pairs of congruent sides. And before we had this major diagonal, which we saw let me change colors, gives two congruent angles here. So again, these two triangles are congruent because of side, 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 which means that these corresponding angles are going to be congruent to each other because of corresponding parts of congruent triangles. And also these non-vertex angles are going to be congruent because of corresponding parts of congruent triangles. But what we want to do for this exploration is look at what the minor diagonal here does. So if this is the major diagonal, we call this the minor diagonal. This is, again, the major diagonal. So we saw before in our argument that the major diagonal bisects the vertex angles. This is a vertex angle. And this is a vertex angle. These are non-vertex angles. And this is a non-vertex angle. Now, let's look at this triangle here. These two triangles that are formed here. Let me blow it up a little bit more. We're just going to look at these two little triangles here. Now, we're just going to talk about these two triangles. Let me shade this in. So we're talking about this triangle versus this triangle. Now, what I'm trying to say here, trying to get everybody to see, is that these two triangles are congruent. This side here is common to both triangles. That gives us a side part of a pattern. These two angles are congruent from our other work, showing that this major diagonal bisects this angle. That gives us an A part of a pattern. And then by definition of kite, these two sides are congruent because this is one of the pairs of consecutive congruent sides. So these two triangles are congruent because of side angle side. And since they're congruent because of side angle side, we can say that this angle and this angle are congruent because those are corresponding parts of congruent triangles. We have two equal angles that need to make up a linear pair. Together these have to be 180, but they're also equal. So this is like a 2x equals 180 or x equals 90, which makes these right angles. So we can say that this major diagonal is perpendicular to the minor diagonal. Also, with these two triangles being congruent by side angle side, we can also see that this minor diagonal is actually bisected by the major diagonal. So the major diagonal makes a right angle with a minor diagonal because these have to be right angles. And also this major diagonal cuts the minor diagonal exactly in half because this point of intersection is the midpoint, since these two pieces are congruent to each other because they're corresponding parts of congruent triangles. So we can say from all that the major diagonal is the perpendicular bisector of the minor diagonal. So in a kite, the major diagonal is the perpendicular bisector of the minor diagonal. Also, the vertex angles are bisected by the major diagonal, and the non-vertex angles are congruent to each other. So those are all, if you're told that you have a kite, by definition, consecutive pairs of congruent sides go with a kite, but also because of these properties, this major diagonal bisects the vertex angles. It also is the perpendicular bisector of the minor diagonal, and the non-vertex angles of a kite are congruent. Okay, let me zoom back in. Let's move on. So let's look at the let's look at this triad here. Okay, so example 1, investigate the diagonals of a kite. We need to go to the Savvas site to see what that diagram is. So this is example 1. So it wants to know what this measure of AXB is. AXB. This is going to be a right angle. Based on our argument from before, this major diagonal is the perpendicular bisector of the minor diagonal because these two triangles are congruent by side angle side, and that's going to be a 90-degree angle. If AX is 3.8, if this is 3.8, what is AC? AC is going to be double 3.8 because half of the minor diagonal is 3.8. The whole diagonal must be double 3.8 since the major diagonal is the bisector of the minor diagonal. Third question, if BD is equal to 10, does BX equal 5? No. There's nothing about this major diagonal being bisected by the minor diagonal. It's the other way around. This minor diagonal is cut in half by the major diagonal. So AXB is 90 and AC is 7.8. So AXB measures 90. And twice 3.8 equals 7.6. So, and that's the measure, well, that's the length of AC. So AC equals 7.6. And no for this one, the major bisects minor, not the other way around. Okay, let's move on. Okay, here we've got a quadrilateral that tells us that it's a kite. So we got the consecutive pairs of congruent sides. Now, we know that because it's a kite, these are going to be right angles. That gives us 90s. And if we want to calculate what the measure of angle 1 is, in this triangle, these have to add up to 180 degrees. So we have 122 degrees. We need another 58 degrees to get to 180. So the measure of angle 1 is 58 degrees. What about the measure of angle 2? This is a 90. Now, if this angle is 58 degrees, this angle over here also has to be 58 degrees. And 58 and 90, again, makes 148 degrees, which means this must be 32 degrees. Or we could have done this shortcut. This diagonal bisects this big angle. If this piece is 32, this piece has to be 32. So I kind of did it the triangle sums way, but by definition, major diagonal bisects the vertex angle. So if half the vertex angle is 32, the other half must be 32. Let's move on. Now we're going to talk about an isosceles trapezoid. A trapezoid has exactly one pair, is a quadrilateral with exactly one pair of congruent sides, or parallel sides. So it's a quad. With exactly one pair of parallel sides. So these sides really have to be different lengths. We're going to see a little bit later that we have two opposite pairs of congruent sides. We have what we call a parallelogram, which has properties that are different from the trapezoid. But a trapezoid has exactly one pair of parallel sides. Now, an isosceles trapezoid has a pair of congruent sides. So QP and RS are congruent to each other. So we have parallel lines cut by transversal. These alternate interior angles are congruent. We can do math with it. If this is 135, this has to be 45. And if it's an isosceles trapezoid with the congruent sides, that means these angles are, we call these base angles, are congruent. So if it's flipped around this way, these are base angles, they're congruent 45 degrees. If it was flipped upside down like this, then this 135 and this 135 would be the base angle, and angle Q and angle R both have to be 135 degrees. So let's look here, part B. Together, this is a linear pair. So if we do 180 take away 47, we get 33 degrees. That means that this angle must be 33 degrees. And now if we did parallel lines cut by a transversal, this is going to be 47 degrees. And same thing here. If we do parallel lines cut by a transversal, let's see, this is going to have to be 47. I'm doing that wrong. This is going to be 133 degrees. This is going to be 133 degrees because that makes the 180. And this is going to be 47 degrees this way. So angle TUR is going to be 133 degrees. base angles of an isosceles trapezoid are congruent. So look at number 4. Given isosceles trapezoid MNOP, okay, here's the parallel sides. Another property of isosceles trapezoids, you might be able to see it better on this one, is that the diagonals are congruent. So this diagonal from P to R is congruent to the diagonal from Q to S. So in an isosceles trapezoid, these diagonals are congruent. So if we go down here to example 4, let me bring this in a little bit. If we go here to example 4, this A plus 13 length is equal to the 2A minus 1 length. So we have A plus 13 equals 2A minus 1. Combine like terms, take A away from both sides and add 1 to both sides. We get A is equal to 14. And it just wants to know what the value for A is. Actually, this is going to be 27, and this way is going to be 27, like that. So each one of those is going to be 27 long. So in an isosceles trapezoid, base angles are congruent. The diagonals are congruent to each other. One pair of sides are parallel. That makes it the trapezoid. And then a pair of sides, the other pair of sides are congruent. That's what makes it isosceles. And we call these congruent sides the legs. So legs are only used in isosceles trapezoids and right triangles. It's the only time you're going to see legs used in relation to a figure. In an isosceles trapezoid and in a right triangle, we call those sides the legs. Let's move on. Now, there's another property of trapezoids called the mid-segment theorem. So if you take the midpoint of one of the equal sides and draw the segment that connects those together, the length of this segment is exactly half this measure, the average of both of these. So they're saying that this is 4/5 xy. So I don't know why they're doing that, but if xy is 25, 4/5 of xy is going to be 20. So it tells us that that's a 20. And they want us to find out what KL is. So this is the one we don't know. Well, in a trapezoid, this, not only isosceles, but in a trapezoid, this mid-segment length, which goes between the two midpoints of the sides, is going to be the average of these. So let's say I let KL be y. Basically, we've got y plus 20, which are the two bases. We call this a base, and this is a base. And if we divide by 2, we're taking the average of the bases. And that's the mid-segment length. So that needs to be equal to 25 according to the diagram. Multiply both sides by 2. We have y plus 20 is equal to 50. Y is equal to 30. So this other side here is 30. If we do 30 and 20 and divide by 2, we get 25. So let's see, formula-wise, now the reason we call these bases, like this could easily be flipped around upside down the other way. So we'd actually have a trapezoid that looks like this, and then we could think of this as the base, which is the long side, or we could think of the short side as the base, which is this side here. So if we talk about base 1 plus base 2 divided by 2, that's the mid-segment length. Okay, let's do these do you know hows. Number 5, what's the measure of angle XQY? Well, okay, vertex angle is bisected by the major diagonal. The major diagonal is the perpendicular bisector of the minor diagonal. That means that each one of these angles is a right angle. So it's going to measure 90 degrees. What's YZQ? YZQ, this angle. Let's see what we got here. If this angle's 56, this is going to be 56. This is going to be 90. This is going to be 90. Well, we got to do some more work here. 90 and 56, 146. So this is going to leave 34 degrees for this angle. 34 degrees for this angle here, because it's congruent, since this angle Z is bisected by the major diagonal. What could we do up here at the top? Let's see. This gives us a 68. We want YZQ. Well, here, okay, YZQ we found is 34 degrees. The length of WY, if this length here is 12 millimeters, since this major diagonal bisects the minor diagonal, this piece here must also be 12 millimeters. So the total length of WY is 24 millimeters. And if they give you units, you should carry the units on through. Let's move up. Okay, we're going to use this trapezoid for 8 through 10. EG is 21. So this distance is 21. So if this is 21 in this trapezoid, DF, in this isosceles trapezoid, DF must also be 21. So we've basically got the question number 9 answered. And they're saying feet. So if EG is 21 feet, then DF must also be 21 feet, since in an isosceles trapezoid, the diagonals are congruent. Look at this side over here. If this is labeled as an 8, this must be an 8, this must be an 8, and this must be an 8. So ED is going to be 16 feet. And the measure of angle DEF, which is this angle here. Let's see what we got. Let's see. If this angle is 77 degrees, this angle is 77 degrees. Now they're showing this whole angle 77. That's 77. This is a quadrilateral, so it has to have 360 degrees worth of measure. Together, this gives 154. And then each one of these is going to be congruent. So we'll call this X. And they're congruent. So 154 plus 2 X's is 360. Take 154 away from both sides. This is going to give us 206 is equal to 2 X's. And divide by 2, X is going to be 103. So this angle DEF is 103 degrees. Okay, let's move on. Number 11, last one here. What's the length of PQ? So here's PQ. This is the mid-segment length. Remember, the mid-segment is halfway between the two bases. It's the average of the two bases. So what we need to do is add 54 centimeters plus 33 centimeters and divide by 2. This gives us 87 centimeters. We're dividing by 2. That's going to give us 43.5 centimeters for the length of PQ. So distance from P to Q is 43.5. If you checked it out, you could double the 43.5 and then make sure that these add up to it. Actually, if let's say they didn't give you what this one was, and they gave you this, you needed to find this, then basically double the mid-segment, which is going to give us 87, and then we subtract the one that we know from it, which is the 33. That's going to give us the 54, which is the one that was missing.